Yeah, so I guess we can start. So welcome everyone. So today we are discussing about the Docker Compose and Docker build pipeline. Uh, I hope this could be the last part in the Docker. Like we've been over like around 4 to 5 different parts in the Docker. Yeah, so the previous sessions were the Docker introduction. So we had a couple of hands-on sessions and yeah, the previous session we went over your Docker file, like we inspected the Docker file. So we didn't go to the Docker Compose yet. So today we'll go to the Docker Compose. Okay. And yeah. So I think some one or two people are new. Hi Jayant, hi Suman. So if people are new, just to give an example. So let's assume you're starting a process, something like Nginx or one second. Yeah. So just to give an overview, so you might be the starting Nginx or you might be starting HTTP, or in a generic sense, you are starting any WordPress process. So or a MySQL DB. So this whole thing we can package inside a container and as an image, and we can run it as a container. Okay. So what we seen is we have a Docker file where we'll write the instructions or simple a Python code, a simple Python code where we basically write a couple of instructions like our code and a couple of instructions inside a Docker file, and we'll put in some attachments. So yeah, so we will put in some attachments and then we will build our Docker file to a image, right? So here we'll also attach our source code, and then we will run a process called container. So here we'll run a process called container. So where a container will have a isolated CPU resources, one CPU or zero point 0.5 CPU. We have a specific set of RAM, 2 GB RAM or 512 MB RAM. Okay. So we can go even dig further. We can provide a folder permissions. We can provide a network permissions. Also, we can attach a GPUs also. Okay. So now today we will look how we can just run a plain Docker process, and also we can see how Docker file will help us to do the process to go smooth. Okay.
Linux ఎంత అయిపోయిందన్న మధ్యలో అట్లా 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 స్టార్ట్ చేసి యాభై స్టార్ట్ చేసిన
So we'll look into a sample Docker file, how we can run a simple one. Okay, something like a Python snippet or something. Okay, so I have multiple Docker containers are running for different purposes here. So what I'll do is I'll take a simple Python one from our GitHub. Two six eight. Yeah, so we have a Flask Docker here, the last time which we ran. So we can take that one as an example. mkdir. Okay, Docker demo. Okay, I think this one has the instructions to connect to DB. Um, so we will go for a simple. Or let's go to that. And in order to show this, I'm using this. So yeah, this is my code. So what it basically is doing is it's connecting to the MySQL database over here, and it's trying to insert the BMI data. Okay, and so we do have a Docker Compose here. Like we don't have Docker Compose for this one. Let me do a git pull. So what I'll do is I'll try to run this one directly. So we have a MySQL and we have a Flask. Give me a second. Please excuse me. I'm just rewriting my key. Okay, not a problem. So what I'll do is I'll just go over a regular Python file and we'll try to spin up a. So what I need here is a simple Python code, a requirements.txt, and a Docker file. Okay. Uh, give me simple, VI. So it just basically gives this hello world from class. Okay. So we'll save it. And also we'll keep this one. So ultimately we have this Docker file. EI. So what we are saying is, so this would be our working directory slash app, and we are installing requirements.txt, and we are opening a port 5000 and run this executable. Okay. Docker -t. So we are building our file with whatever the Python code we provided. Okay, it just basically prints hello world. We'll try to execute it. Oh God. So this is our image, Flask hello, whatever we built right now. So we'll try to execute it. Okay. So Docker run -p port 5000, and our image name is this Flask hello. Okay. Port 5000 is already in use. So what we do is we'll use a different port number here, and So the format would be host port and container port. So I'll change it to 5001. So my Flask has been started. So like the Docker container has started. So it started in 5001. So what I'll do is I'll go and check if my process is coming up. So 0.4. So we got the hello world. Okay. Now here, when we are running, we are providing these parameters, right? So it should run as a daemon mode. It should be the port numbers. Okay. Let's say assume we give a storage. In that, if we give a storage, we need to specify all the things. So instead of this, like let's assume if we are going further, like all the parameters would be more. Like what and all things we can define here is. So what and all things we can define here. So CPU limits, volume mounts, credentials, networks, and we do have a health check. Okay. And other than that, we can provide dependencies. Like if you have multiple Dockers, so we can provide dependency like it should start after first Docker container. Once it started, we can start the next one. Okay. So we will see this example also. Okay. So this whole things we can keep it under Docker command as well, but instead of that we will try with the Docker compose. Okay. So first we will check if we have a Docker compose. So we do have Docker compose, and how do we install it? It's the standard version like apt sudo apt install. Yeah. So it's already installed. So what we'll do now, I'll write a simple Docker compose for this one. Okay. So vi docker compose dot yaml. So if we see here, so we are specifying the version is 3.9, and here everything is a service. Service as in, let's say assume you have here only there is only one Docker container. Okay, something like a web flask. Okay, so this would be one service. So you can specify a different thing as a second service. Okay, so something like ADV. And these two things can communicate each other if they are under same network. Okay, so here it is called service, and the service would be helpful as a DNS name. So let's go ahead. So what we mentioned, the same things. So we wanted to build the container when it is starting up. That's why we gave the build instruction. So we gave our container name, how it should look like. So let's give our port name should be 5001. Okay. And restart unless stop. Okay. So if you want to auto restart the container, so we can give this command. So what we'll do, we'll remove our build, previous build, the zone, Docker RM, image. So should be image RM Flask. So Docker container prune. So our image has been deleted. So what we'll do now, we will give a simple command docker compose up -d. So if you see here, it is trying to create a network, Flask demo default. So we didn't specify anything. It's trying to create its own network as a default bridge. And it's saying image app was built because it already did not exist. To rebuild this image, you must use Docker Compose build or Docker Compose up-build. Okay. So if I want to rebuild, so this is what. So now if I go and check my container, so this is what it is up 41 seconds ago and it's in port 5001. Okay. So let's go and check that. Yeah. Can close and reopen just for reference. So this is just a simple, like a simple overview of Docker Compose. But if we want to see a complex example, right? So we do have a similar one. If you take a look at this one, mun Docker, right? Last time we tried to execute the mun Docker. So for people who are like little new to this term mun, so we have mun for MongoDB, Express, React, Node.js. Okay. So we try to spin up a container using all these technologies. So one database, one backend, and one frontend. Okay. So what exactly we did? So we build the Nginx as it is. So we didn't do build again. We have a front end here. So yeah, front end, it's just a plain HTML. Think, and then we have a server.js. This is the backend. Okay. So we use, yeah, and we have a MongoDB. So what we'll do is we will see how to spin up these things manually, and then we can see how to spin up these things with the Docker Compose. Okay. Uh, I doubt if I have that commands in my history, but let me see. Yeah, the name is MERN, but I didn't use complete MERN stack here. So we have a Nginx, we have a front end, Nginx and backend. Okay. So if you see my Docker Compose, yeah. So it is saying this. So you start a MongoDB service, and then you start a backend, and then you start a front end. Okay. So how do you know exactly it's saying MongoDB service? So what we'll do is, so we have a dependency. Okay. So what is the dependency? The first DB has to be built, the database has to be built, and after that your backend has to be built, and after that your front end has to be done. So that's the order we are supposed to follow. In order to do this via Docker, so this is how we do. So history, grep for Docker, Mongo. So this is the command docker run -d mongodb/data/db. Okay. So let me check if I have a volume for with that name. Docker volumes. Yeah. So we have a Mongo data volume last time when it is created. So we'll reuse the same thing. It's fine if we don't need to create a new one. And if people are new, like who is wondering, like what is a volume? So volume is a storage attachment here. So when a database is reinitializing, right, when we stopped and started the database, we want to store the previous records also. So that's the reason we are using the volume. So if we see, so we have a dependency, we have a volume attached here, and also we have a network. So let me see if that MERN network is there. No, MERN network is not there. Okay. So first thing, so we'll create a MERN network. Okay. And second thing, so we are using the MERN command. Okay. So docker run -d. We have our database name is database is MongoDB, and we are using the open source image which is Mongo, and we are using the volume which already we have. We are reusing that, and we are giving the port number as this. Okay, so yeah, it's pulling from the Docker Hub actually since it doesn't exist. So we'll go through that. We'll show you what is Docker Hub and what we are doing there after this step. So far, any questions here? I didn't started the Docker Compose. Actual Docker Compose, I'll show you. So far, any questions here? Prasad, someone?
Nothing as of now.
Hmm. So, so here I'm doing a Docker build for my backend. So, and then I'll run my Docker backend command. So, yeah. So backend already exists from the previous time. So we'll remove that. Then okay, we have running Portainer, so I'll stop that. One second. Okay, we have this one also. We run. Okay, so now we have our port number. Now we are able to open this Docker backend. So let's see the logs. What exactly is happening? So Docker logs backend. So it's running in port 5000. So now we will start the front end also. Okay. So I built a front end image and then I'm running it. So it's saying for this one also board. So mm, I can give a different port, but for our convenience, it's okay. So we have a Grafana running here. Uh, So we have a front end started. So what and all steps we did? So here, first step is we created one volume, one network first. Okay, one volume, and then we built a image, right? So we ran MongoDB container, and then we built backend, and then we ran the backend container. Okay, so again we are doing the front end, run front end container. So if you ask me, build is necessary. It's not all the time, but it is okay to do it. Okay. So we have all these steps and we are doing these things manually. Like, so in production environment, if you see, we have multiple Dockers, right? If you see my ls data one, see, all these are all Docker related apps only. Okay. Everything Postgres, Portainer, Residio, everything is a Dockers. So we have Uptime Kuma, that is also a Docker one. So me going there, running that commands, everything, it's a manual thing all the time, and I might not remember what is the ports I attached or anything. Okay. So instead of that, we will do a simplification with the Docker Compose. So let me see if my front end is running. So Docker logs front end. Okay, it's running and it started in port 3000. So let's check that. Okay. Uh, Looks like get address info not found Mongo. It is unable to find the MongoDB. So I might need to kill and restart everything. So Docker RM, backend, front end, force, Docker PS, grep Mongo. Okay. So the name we provided is the MongoDB. Let me rename that one. Okay. Docker RM. So let me start it again. So this is my container name where other containers will try to interact as I told as a DNS. So let me see my name again. So we have Mongo. Now I'll start the backend. Okay. Now I'll start my front end. Let me check the backend logs once. It says MongoDB connected. So now I'll run my front end. Go and check. Okay, I think for some reason this also is not starting. I think maybe somewhere we are doing a mistake in the manual spinner. So what we'll do, we'll clean it up and let me check the backend also. So backend is port 5000, right? Yeah, my bad. Yeah, I'm giving that proper name, backend. Backend, and again, okay, now I'll see the logs. Yeah, I think this browser is not refreshed. Let me take a fresh one. Oh, 3000. Okay, I'll try with the Docker Compose. Maybe someplace I'm doing a mistake. Okay, so mm, so let me see this Docker YAM Compose YAML. What is it? So what we are saying is, so we are saying three services: MongoDB, which will run under this one, and we have a backend, which will run under this particular one, and we also gave a link as an environment variable. So how it will connect to the MongoDB, and we specified the port number here, and we also specified the demand depends, as in first the MongoDB should be able to run, then we can start this, and then we have okay, this is the problem, I think. I'll give one more shot. I think. Yeah, I'll give one more shot. Please don't mind. So go.
See, I think in our front end code you mentioned 80, right?
Yeah, man. I am trying to rewrite the code. I'm trying to rebuild it from 80. Okay. One second.
Yeah.
I hope nothing is running in port 80. Okay, this is a previous one. Yeah. Solo system CPL. Stop Linux. Okay. Okay, finally we are able to get it. So what happened to my okay? This is yeah. Let me see if my backend is running fine. Backend. Okay, it's running fine now. So let me go and hit again. So 2, 3, 4. Yeah, somewhere something is broke. Maybe for the back end or front end, we don't know. Uh,
Yeah, your compose file shows that is 3000 for container and sorry for host and 80 for container, right?
okay, yeah, let me check once. Okay, it should be 80 only, right? It should be 80 only. It doesn't matter. Like this port can be run on 3000. That should be okay. I think this is something with the backend, the server problem. Maybe the backend didn't initialize properly. So it's okay. We will try to spin it from the Docker Compose. Okay. So Docker RM front end backend Docker network rule. volume. Okay, so we will try to spin up this one using Docker Compose up hyphen build and -d. Yeah, it did everything. So let's check the logs. Okay, it created in a different format, but that's okay. Yeah. So we can hit slash users, I guess. Where we should get the user data somewhere. Yeah, let's check what and all it created. Okay, Docker. It didn't give any names, man, but that's okay. Yeah, it exposed on port 3000 to 80. Okay. Let me check that. Yeah. So we are able to get the past IP addresses. It's stored from the database and we should be able to get it. So that's about the Docker Compose. Like the difficulty, I think you seen practically, right? The difficulty with the networking, the difficulty with the storage. So to maintain everything and to run it like manually and all, it's a wholesome process. So what we can do simply, we can just go there and spin up with the Docker Compose. And we can also add a health check to it. Okay, so that would be here. So yeah. So here we have the main things: versions, services, volumes, configs, and secrets. Somewhere it should be health checks also. Yeah. So here we have a health check where it will continuously check the health of the container. Okay. So if your container is supposed to run on port 80, so what we can do, we can reuse here. Okay. So here, let's say if your container is running on port 5000, so we can add this one as a health check here. Yeah. So this is the health check. So where it will verify if it is pinned up properly or not. Okay. And you can do the same for the backend also. Well, we will give a try on this. Okay. So to bring down all the Docker Compose created things, right? So it's too simple. So we'll go here, Docker Compose. We can provide a YAML file here, like what is my file name, -f docker compose.yaml. So instead of, since I'm in the same directory, yeah, it's cleaned up everything. So what I'm gonna do, I'll update this one with this. Okay. C and vi compose.yaml. Okay, so let's see. To bring it up, so what we'll do, we will do a rebuild and with the daemon mode to run in daemon mode. Yeah. So if you see here, right, the health is saying starting. Okay. So it doesn't say health is good and all. Health is staying starting. Okay. So let's see. Refer. Yeah, health is still starting because, as you know, first Mongo is supposed to be spinned up and then the backend supposed to be spinned up. So what happens is, let's assume here if the backend supposed to fail or somewhere, if it failed or somewhere, the Docker will report, container will report that okay, uh, it's still failing some point. Okay, so maybe let's see if I gave a wrong command here. I think I referenced a wrong port, but let's check. Okay, I think it's still waiting for the time because uh, interval is 30 seconds. So let's hold on. Yeah, it's still coming in starting stage. Okay. So any questions here till now? Sumant, Prasad, any questions?
Nothing, Sasi.
Okay. So till now we are storing our images locally, right? Yeah, I think it's still coming up. We will take a look later. Maybe if we define the health check wrong or somewhere, or if the container doesn't have a curl command, it will fail. So it could be any reason. So that should be okay. So what we'll do, we have till now, we are storing the images locally. We are not storing anywhere. Let's say if I'm supposed to pack my image and send it to you, I cannot do it directly. I need to send my source code and all. Instead of that, maybe there is a simple way with using the Docker container registry. So there are multiple container registries. So we have a Docker Hub, which is a famous one. We have a Bitnami. For AWS, we have ECR. And for Google, we have a GTM. And Azure also something is there. I don't remember the name. But, okay. So whenever we built our file locally, the Docker Compose or source code, right? So we have a source code. So let's put it here. Yeah. So we do have a source code. The source code is nothing but your Docker file. And what we can do, we can take this source code and we can build it. Okay. Build a image out of it. This image we can store in the different container registries. No. So what is this building and what is this storing and what is it exactly we are doing here, right? So let's say I made a file, I made a change in my code here. Okay, somewhere here or script or somewhere I made a code change. Okay, so what we are supposed to do, we are supposed to build a next version. Okay, earlier version is 1.1. Okay, now we are supposed to build 1.2. Okay, and 1.3. So let's assume every image size is somewhere around 500 MB, or let's say you can check here how much it is. See, 180 MB it is, or some places it is 1 GB or so. So you have one is 200 MB roughly. You have 5 images built, that will be like 5 GB. Okay. Sorry, 1 GB and more. So now what happens? This whole thing will bloat your storage. So you need a central place to store your images. So you can use the Nexus artifact registries, Nexus and JFrog. You can host locally also. That is also fine. As in a data center, you can host the containers locally. So that is also fine. So now what we'll do, we will see how we can push our image to Docker Hub. So here I have Docker Hub and all. So now I have my something called repositories. Repositories, under that we have images. So that's the format. So what we need to have, we need to have a ECR. Under that we need to have a repositories. Under that we have our image. Under that we have our versions.
So
That
are,
is called tag.
are we going to keep the images in the repository locally, right?
No, not locally anytime. See, all this thing I built in my laptop, right? So now when you're running in production, you don't want to pull the image from your laptop. And this is wrong. You're not supposed to build an image, right? See, you are a developer, you're testing it. Fine. You build an image and you test it and you ran fine. Okay. Let's assume I'm a DevOps guy. I'm not supposed to build an image because I'm not supposed to change the code, source code, and I'm not supposed to build it. All I need to do is I need to take a you will certify, right? Let's assume a tester or a developer will certify, saying like, see, this is the stable version is 1.5. Okay. Let's assume you certified it. I'm supposed to bring this version to the production. That's my job. So I'm not supposed to do this. What is it? I'm not supposed to edit your Docker Compose file and Docker file or anything. I'm not supposed to change it. All I need to do is take this image and build it in, run it in production. So I'm not involved in the build process or code process. So and that is wrong. It's not a standard. Like only ops guy is supposed to take care of the running the production image, and dev guy will supposed to take care of the building the image. Why is that? Because someone has to go and certify this image is the bug free and there are no vulnerabilities at all.
Got it.
Yeah. So if I'm keeping in a single VM or a laptop, this process will not go ahead. Okay. So now what we are doing, we are trying to store this. We are going through process of storing these images. Okay. So the first step is Docker login. So yeah, mine is running in Linux Ubuntu. So otherwise it will open a browser. So earlier it used to take the usernames. Okay, let me try usernames. Okay, yeah, pat. So we will see what is this pat later point of time. So now if you see, like I have my login succeeded. So I'm inside the Docker login is working now. So I'm connected to the Docker Hub. So what I can do, I can check my images. So I have this image, right? My backend image, Flask and Mun, right? So what I'll do, Mun, I'm not building anything. So backend is the only one I'm building and Flask demo. So let's check my compose file again. So image we are using already, backend and front end. Okay. So let me do one thing. This one, Docker rm. So what I want these two images to be pushed to the container registry. So what I'll do, I'll rename it properly. So I have a mun docker backend flask demo. So I'll standardize the names. So what will I do? Here we are following something called tags. So we can follow a version here or we can keep latest. So what will I do? I'll give version. So docker tag. This one. Latest to what is it? Sesi Mun V1. Where is Sesi? So yes, my image is ready here. So Sesi Mun and my version is V1. So I'll tag the another resource also. So tag as in I'm changing the labels and all. Okay. Like what is the repository supposed to be? What is the tag supposed to be? Those two things I'm specifying. So I'll take this Flask demo. So Docker this Flask app. Yeah, I think only backend is needed. I don't need anything because see here we are using front end. We are using Nginx to build it, right? Okay, let me see that. Yeah, let me rebuild it. Second. Yeah, we don't need this. We don't need this. We don't need this. RM backend, front end. Okay, I'll simply do Docker compose down. Yeah, I forgot. So this is what's supposed to be. This should be fine. Okay. Now, yeah. What will I do? I have all these things here. I'll just do Docker compose build. What it should be up hyphen build. So it's running the building the backend image. It build a front end image also. So let me go and check the images. Okay. Yeah, I'll remove this thing. I'll build it again fresh. So yeah, let me check again. Grep backend and grep front end. Okay. So we have everything related to Mun itself. So what we'll do, we will tag it properly. Okay. Docker tag. So this should be Merl backend v1. This is the format. Repository, backend, and then v1. And the Merl frontend also, we will take it. And this would be Merl frontend v1. So what we'll do, we will push Docker push. Yeah. So the ID is going to docker.io/merl/backend. So request to resource is denied. It's supposed to create a repository here. So what we'll do, I'll create Merl. So here there are private and public. Okay. So what I'm doing, the public is the one which all other people can see. So for now, I'm using private. That should be okay. Okay, it's already used. So Merl. Okay, so it will come under my name, Merl. So any changes, anything that will come over here. Okay, so let me try it again. So the name should be Sesidattam slash. Yeah, so it should be this one. Yeah, I think I need to tag it properly again. Docker tag. Uh, to. So for now, I'll just use this image. Okay, so Docker tag v1. Docker push. So I just pushed the backend image. So that's enough for now. I'll go and check if it got reloaded. I don't know. It's still, yeah, it pushed. So let me go and check. Yeah, so we have a v1. So wherever we want this particular image, so what we can do, basically we can go to compose. So instead of building, we can just specify Sesidatta /merl/v1. Okay, so Docker compose. Yeah, so it reuse the command. It reuse the container. Okay, so in case if you are wondering, like maybe there is a residual entries, so let's clean that down. Okay, Docker image prune. Grep content. Yeah, let's remove this one. Docker image rm. Yeah. Now let's do the Docker Composer. Yeah. So it's trying to sorry, it's trying to pull the image from the what is it? It's trying to pull the image from the Docker Hub. So it took some time, but it did, and our image, our basically our application is up. So this is the process of pushing the container to either a Docker Hub or ECR. So the commands like vary a slight a bit. So it's mostly the same. And when we are doing, we do have yeah. So we are do have something called PAT. Okay. So if you go to here, account settings. So we have something called this one. Yeah, personal access token. So let me delete this one. And this is for demo. Expiration date. So it's better you keep some time. Read, write, delete. Read and write ideally. So generate. So I'll take this and save it. Okay. Now what will I do? I'll write a pipeline for this in order to build a backend, a pipeline where it will build an image and push it to Docker Hub. Okay. So let me open this one and cd repos, cd docker underscore demo. Okay, no problem. I'll just try one more time. Okay, I'll go to my image. So Docker demo. I can go to backend and I can do the build from here. Okay. So what will I do? First, I'll pull this repo. So Docker git clone. Okay. And I'll open that in VS Code just for our understanding. Yeah. So here is my file. So what will I do? We'll add a GitHub action. Go to here. So Docker image. So we do have a GitHub action available. So build a Docker image, run, deploy, push to a Docker registry. Okay, so let's check our branch name. So our branch is master branch. So whenever someone pushes changes to master branch or creates a pull request, so it's supposed to build the Docker file, and yeah, it is tagging my Docker file. Okay, so I'll give one thing. Let me get the path. CD learn CD backend. Okay, so CD learn slash backend. And Docker build with the file Docker file and tag my image name. So we can give anything, but what we can give something like we customer. So this one is building the Docker, and so we are supposed to do the Docker push also. But let's see. Let's try to do this. Yeah, in order to trigger this, we don't have manual switch. So let me see. Yeah, it did trigger the first one. CD man. Just- Yeah, CD man hyphen Docker. Okay, so let's rephrase it. Yeah, it did build. It is building the image. So what we want is we want to add a push command to it. Okay, so let's go to our Docker Hub. So we have a this one push command. Okay, so we need to add two steps here. So one is Docker login with the pat, and one more is push command. Okay, so let's add both of that. Your GitHub actions would be under this one dot workflows, and so let's add push. Okay, so let me bear this. Let's keep our comments ready. Yeah, this I copy pasted locally from a different one, different repo. So this, okay. So here we are saying Docker Hub username and Docker Hub password. So we are supposed to specify that. And yeah, let's add these two things. Okay. So go to your settings. Here somewhere actions, secrets. So I'll add a repository secret. Okay. My Docker Hub username. And I have this password as in token. This is the token. Let's add these two things. So either we can push with the date or SHA, as in every push, whatever every commit you have a SHA code, the SHA-SUM hash code. So we can use that one as a version. So anything is fine. So I'll just keep as it is. And yeah, think yeah, I should be able to use this. Okay. So yeah, Docker push and SHA should be able to do this. So this is up to here. So I think this is done. So the push is completed. So what we can do, we can go and check. So we got one more push. So this is the tag it came. It came with the your GitHub like your commit as such, like commit hash code. Okay. So what we'll do, we will change a little source code change. Okay. So what we'll exactly do is like maybe a front end line change, but back end we are not doing anything. So development env. So what we'll do, I'll just commit this particular one, mention updated Docker backend Docker code. So the build should happen again, trigger. Yes. Okay, git pull. Git push. Okay, my change is succeeded. So let's go and check in the GitHub. Yeah. So now I just did a change, like I made a code change. So it automatically triggered a pipeline. So it's rebuilding it's rebuilding the image. Okay. So earlier we were able to integrate this tool. There is a Docker image vulnerability check actually. If you go to it. Trivi. Okay. So if I go to here in actions, yeah, so here it is. We can reintegrate this one with our code. Okay. So go to here. So build the image. GitHub run. Yeah, this is the one. Image reference template. Okay. I think it needs some more changes. Yeah, I think. Okay, it does regularly scans this. I could not completely do it, but it's okay. We'll give it a try. So we'll keep this one at the last. And so this is one mer. So I integrated Trivi in our pipeline. So let's go and check what exactly happens. And it doesn't fail our pipeline, as in like you can still push, but you will get a certification. Okay, so whether you are able to do it or yeah. One second. Yeah, I missed this step. Something I missed. Can check here. Yeah, result. Should be good. Yeah, I think there is some problem. It is unable to recognize it. So I think I'm supposed to give it token or something, but that should be okay. We can able to check that part later. So yeah, that is how an industrial pipeline works. So for ACR, like ECR also, it works in similar way. Just for your idea, I'd be showing that. So we can go to AWS console. Yeah, I think I can try for this one also. I'll show you. So here we have one repository, Sasidatta. So what we can do here, so here we have the push commands. So we can initialize the AWS container with the AWS CLI, and then we can do this one, AWS login, the similar commands, build and push. Okay. And if you want for GCR, so let's log into Google Cloud console. Yeah, I have my project here, Sandbox. So I'm looking for containers, GCR. Yeah, this one. So here there is a standard repository already, the default repository. So there is a scanning facility. Nowadays, the scanning facility available inside the repository itself. Okay. So yeah, I think very long back I did Flash talk for the Flask Hello. So yeah, it also follows the similar thing. So we are supposed to provide the authentication tokens and all. And yeah, so this is what we are supposed to do the gcloud auth. So we need to set up a gcloud CLI. We'll do the build and then we'll do the push tag build and push. So it's the same commands, all the whatever cloud it is. So it would be the same commands and the pipeline would be the same. Yeah. Press someone. Any questions, man?
Nothing.
Yeah.
Nothing, Sasi.
Yeah. Prasad, do you have any question?
No, Sasi. Currently, it's good.
Yeah.
I'll try
So
to.
ideally, sorry.
No, I need to practice with this one more time and then.
Yeah. So yeah, you might need to practice that. What is it like? Ending of end-to-end pipeline, as in. So either you can do locally with Jenkins or GitHub. That's fine. So ideal flow is a developer will push the source code, as in the. I mean, what I've seen in different environments is I never had access to a in particular org, so I never had access to the source code. Okay, so they have the source code and they'll push the Docker file, and then they'll give the they'll push the image to the container registry. Okay, this is for the dev and test. Yeah, different orgs follow different structure, but ideal thing would be like, so they will be building the source code from there. They will push to the container registry, and the ops guys would be. So right now, I'm not touching the Docker. What to say? We have Docker Compose and which one it is? Docker Swarm. So I'll try if we can cover in the next session Docker Swarm. But I'm not going to the Docker Swarm and all. So either we want to run the container as a Docker, okay, we want to do it as a Docker Swarm, or we want to do it with the K8s, Kubernetes. Okay. So all we need is an image and then the parameters to run. What kind of parameters to run? So ideally, at the end of the day, the ops guys will have a what to see. The ops guys will have a structure only for this one, the visibility up to here. So the dev team or the test team will able to push their image up to here. So if you ask me, how do they know Docker or how will be able to push it, the pipelines and all? So that's the task of DevOps engineers, as in the principal engineer and DevOps engineer, to help set up the pipelines. But after that, we won't touch anything. So, and there is a thing earlier. The problem with Docker is, I think in the beginning we discussed, Docker is a multi-purpose tool. So you can build an image and then you can run it and you can troubleshoot. Okay. But this becomes a bottleneck in production where someone using Docker, they can build a live image and all. So that could be a problem in the production. So that's the reason they were splitting it up and they were going with the CRI. Container.io. Okay. And we do have one more thing. Forgot. We have builder for builder, or a different thing is there. Either we can do with the doc, other things. So you see. Yeah, we do have Podman and other things. But the main difference is this one. So Docker comes with a Swiss Army knife, like whether you can build a live image or you can push and all. So like I don't need authentication for CLI, right? Like I don't need authentication for the container registry. I can just do it locally and then I can run it in a production one. So that becomes a security issue. So that's the reason we were using the container registry in production environment. Okay. So that would be CRI, container runtime. It is. Yeah, this is the one, container D. So instead of Docker, we are using CRI-O or container D. So as a mandatory one. So yeah, that's all. I think we can conclude the Docker topic here. Thank you, Prasad. Thank you so much for joining.
Yes, see, just a question that so dev team will build the initial Docker file, or as a DevOps engineer, we need to build that initial Docker file.
Okay, let's say assume dev team knows Docker in and out. Okay, so everything. If you're asking in the terms of process, if they don't know, we can help them set up this thing. Like now, how did I set up the pipeline, right? This thing.
Mm-hmm.
So we can set it up for them and they can start reusing it. Yeah. But ideally, it should be the dev team should be able to build from the source code to the container registry. I mean, they don't need to do anything, right? They just change their source code. Everything, the image will be ready. Correct?
Yeah.
Yeah. So we just facilitate that situation. Like you need a image, so we'll give a pipeline for you. You do whatever you want. So I mean, depends. There could be admin team, or there could be a principal engineering team, or there could be a DevOps team. Some places SRE is the one. So we build a blank repository, a hello world repository or a blank Docker file, and then we will put it to container registry. So then they can come and put the source code. And here we are doing one container. Instead of it, we can build a different containers going into different folders and all. Yeah. Does that answer your question? Sorry.
Yes.
Yeah. Suman, do you have any questions, man?
Nothing as of now, Sasi.
Okay. Stop it.